Thank you. All right, well, I'm going to kick us off here. Good afternoon and welcome to everybody. We appreciate your interest in ecological forestry and in birds. I'd also like to thank Xander and the Forest Stewards Guild for giving us the opportunity to share our research regarding forest management in a system that is growing rapidly in Europe. The approach is called Close-to-Nature Forestry, or CTNF, and we have a research forest in Ohio that has been using CTNF management for 7 years. And today's presentation will give the results of our first avian research project in that Ohio forest. Dr. Corder and I are the co-authors of that paper, which was published in the UK scientific journal Avian Biology Research in November of last year. Today's agenda is shown here. I will start the presentation with our conclusions, combined with a few brief highlights of our methods and our team. Then I'll briefly describe European CTNF, silvicultural approach that is often misunderstood or misrepresented in forestry literature. CTNF has undergone an evolving and varied definition, even within Europe, over the past 3 or 4 decades. But key aspects are converging, and those will be highlighted in our presentation. Then the bulk of today's presentation will be dedicated to the content found in our discussion section of our paper. Dr. Corder will cover avian trends and some important forest observations in both the US and Europe. I will summarize our review of guidelines for forest bird habitat management, which we utilized in our study. Then Dr. Corder will review our field data and evidence for our conclusions and recommendations. As a quick precursor to our conclusions, I'll begin with a few highlights about our methods. The title of our study was Assessing the Effects of Close-to-Nature Forestry on Forest Birds in the Eastern United States, a Case Study and Way Forward. Intentionally calling this research a case study, we acknowledge limiting factors to our conclusions. First, the study area has only been managed by CTNF for 7 years, a short temporal period for forest analysis. Next, the study area has a modest spatial scale, even though we did use eBird data from a landscape scale area. Furthermore, eBird data has its shortcomings, and we'll discuss those later. Despite the limitations, however, we hope this study will generate further interest and future studies that will benefit from our work. So let's start with the study area. It was a 122-acre oak hickory mixed hardwood forest in the southeastern ecoregion of Ohio. It is a second growth forest, roughly 80 years old. It was naturally regenerated on abandoned farmlands and former strip mines. It is a mature forest with closed canopy, minimal understory, and very little coarse woody debris. It is also part of a larger 273-acre mature forest, which includes a wilderness preserve. The study area has been managed by CTNF methods since 2015, with 3 spatially overlapping harvests between 2016 and 2021. The forest is divided into 16 management units, which are measured extensively and which now have varying degrees of post-harvest canopy closure. Avian point counts by sight and sound were conducted at a dozen test locations within the forest from February through July of 2021. Test plots were selected for a sampling of different habitats based on canopy closure and edge versus interior effects. The canopy categories included open, having less than 50% closure, closed, more than 80% closure, and an intermediate category. Edge effect habitats were defined based on their distance from the forest edge. Edge habitats were less than 50 meters from a forest edge, and interior habits were greater than 100 meters from a forest edge. Our landscape scale analysis utilized eBird data from the county where the study was located. That county is 571 square miles in area, and we compared county eBird data to data from our forest for the period of May through July as an indicator of breeding season presence. Then, as noted earlier, we reviewed forest habitat guidelines for Ohio and for a broader surrounding region. One guideline was for the southeastern Ohio ecoregion where our study area is located. We used that manual most extensively in our data analysis. However, we ultimately reviewed a total of 17 different manuals to see how the Ohio recommendations were similar to or different from other guidelines in the broader region. Okay, so let's look at our conclusions. Based on this site, as well as on the more general research material we reviewed, our first major conclusion is that CTNF management promotes avian diversity in Ohio forests. Our evidence supporting this conclusion include, at a local scale, our CTNF habitat attracted nearly an equal balance of both early successional and mature forest bird species. That balance is notable since the CTNF harvests are predominantly single tree removals that produce small canopy gaps and are commonly viewed as a mature forest structure. This evidence is based on our examination of species presence and richness in different locations within the forest, interior or edge, and under different canopy structures. At a landscape scale, our CTNF habitat attracted a greater proportion of birds having a high conservation concern status when compared to the regional eBird data. Given the diversity of birds, their spatial patterns, and the characteristics of habitat features, we concluded that our CTNF habitat functionally achieved the creation of both early successional and mature forest habitats, even though CTNF protocols are very low severity with mostly small canopy gaps. And finally, based on our review of forest habitat management guidelines, effectively all guidelines recommend a balanced approach for selecting forest management techniques, which seems very appropriate. In other words, some bird species need early successional habitats, other species require mature forest habitats. Thus, unless you're predominantly targeting the care of one specific species, you should use a mix of management techniques, some early successional and some mature forest. Our review, however, combined with our field observations, raised a question for us, namely, is a balanced management strategy for avian forest habitats more likely to perpetuate landscape scale fragmentation? In our discussion section today, we will get into all these conclusions and questions in more detail. Before we move away from conclusions and methods, I'd like to acknowledge our team and give a little background on our CTNF research. I'd like to start with our primary forester who designs and marks our CTNF harvests, Ed Romano. Ed is in the red plaid jacket, instructing loggers in the upper photo and examining trees with me in the lower photo. He started his forestry career in 1966 with forest fire training in Ohio and Wyoming. In addition to getting a forestry degree and graduating from the National Hardwood Grading School in Memphis, Tennessee, Ed has been a certified forester, an inventory forester, a logger, and a sawmill operator during his long career. His passion for ecology and extensive experience give him a harvest intuition that fits CTNF protocols very nicely. The next contributor is my co-author, Dr. Jason Corder. He has already been introduced, and he is our bird expert. For the measurement of our forest characteristics, Henry Lieberman has provided detailed forest inventory analysis, including standing volumes, stocking profiles, coarse woody debris, logging damage, regeneration assessments, and uneven aged management plans to compare with our CTNF approach. Henry is a certified forester and a certified arborist who has his bachelor's and master's degrees in forestry from West Virginia University. He's worked for Weyerhaeuser as an inventory forester and now has his own forestry consulting business. Other important contributors include Dr. Calderhead, professor of mathematics at Malone University, David Mudrak, who measures our tree diameters consistently and with great care and accuracy every year, and numerous forestry experts from Europe who are practitioners and industry leaders in CTNF. The final background information then of our study is that really the CTNF activities that I lead in Ohio. After retiring from a long career in corporate America, I invested in an Ohio forest in 2011, and that forest investment sparked a new career for me. After a few timber harvests, I started investing in more timberlands and returned to college for the degree in conservation ecology, which I completed last year. So now my career is timberland investment combined with forestry research, with a primary objective of ecosystem improvement and a secondary objective of economic profit. Since 2016, we have been doing 1 or 2 CTNF harvests every year for a total of 9 harvests so far that sold over 750,000 board feet of hardwood timber. And we are expanding our forest land ownership. This Ohio map shows forests we've purchased and studied since 2011. Although we've sold 2 smaller parcels, we are steadily increasing our holdings toward the 2026 target of 1,000 acres. In terms of research, our activities start with learning from those who successfully practice. I am a member of CCFG, the Continuous Cover Forestry Group based in the UK. And I've attended several of their ecological forestry conferences like the one pictured here. This organization has allowed me to gain mentors and advisors who are CTNF experts located both in the UK as well as in countries of Central Europe. From discussing research data to reviewing our technical papers to clarifying the reality of CTNF use in Europe, learning from those who do has been invaluable to our efforts in Ohio, where we test CTNF methods and adapt them to our forests. A key metric for CTNF management is annual diameter increment of our trees by location and species. We monitor more than 1,000 trees, which are permanently marked and annually measured. The photo shows our marking method, and we use the data to assess growth rates and plan our harvest frequency. Although our marked trees are typically spread widely throughout our forests, we also utilize a higher monitoring density like the one shown here when we are assessing the growth implications of a site with particular characteristics. And finally, under the category of research, we measure and monitor our ecosystems with metrics and special studies, such as the bird-focused one we are reviewing today. But before we discuss our specific study, I finally wanted to spend a moment on the question of what is CTNF? Pictured here is the front cover of a CTNF field manual published by ProSilva, the international organization that promotes close-to-nature ecological forestry methods. This particular manual was translated into English by ProSilva Ireland, and I highly recommend it as a resource. As a framework to define CTNF, I'd like to discuss what it is and what it isn't. Most importantly, CTNF is a system that permanently protects the forest canopy. CTNF is effectively equivalent to continuous cover forestry, CCF. Newer European literature uses the terms CTNF and CCF interchangeably or together. What does permanent canopy protection mean? It means never clear cutting and never removing large portions of the canopy. Small canopy gaps are the norm, but occasional large gaps, up to 1.3 acres, are allowed. Influenced by the growing CTNF trend, 19 countries in Europe now define a clear cut as any total felling that is larger than a half hectare or 1.3 acres. CTNF canopy protection is largely achieved by rubrics controlling canopy gaps and biomass removal. Another major objective of CTNF is biodiversity improvement and resilience to climate change. Harvests should maintain or improve tree diversity. No high grading is allowed. Furthermore, harvests should be designed to remove the lowest quality commercial trees first, thus improving the health and quality of the forest over time. The use of natural processes is also a major objective, reflected even in the name CTNF. Natural ecological variation and complexity are embraced. Use of chemicals is avoided. Management interventions should move the forest toward old growth characteristics. And finally, the forest should be managed by frequent harvests of low severity. Average harvest rates should be below the forest increment for sustainability. Maximum biomass removals in hardwood forests should be between 15 to 20% of standing volume. Tree diameter measurement is critical when managing for CTNF. And perhaps the most important word in this bullet point is frequent. By taking small intervention steps and frequently harvesting in the forest, practitioners must observe the forest continuously, making small changes as the forest responds and develops. And regarding what CTNF is not, the first item is CTNF is not single tree selection. Somewhat confusingly, CTNF is classified in the US forestry literature as single tree selection. However, there are fundamental ecological differences between single tree and CTNF. Although single tree selection in the US was modeled after European research in the late 1800s, single tree methods codified in the US during the 1940s dramatically deviated from the methods used in Europe. One example is the use of equation-based ideal stand profiles called reverse J or BDQ curves. In single tree selection, these curves are used to guide the thinning of stands and to increase tree-to-tree spacing. In Europe, CTNF does not use these ideal curves and generally allows the natural occurrence of overstocking, including the presence of pioneer species. The net impact compared to single tree is that CTNF methods have much less biomass removal, more structural complexity, and greatly reduced intervention requirements, which lowers management complexity and costs. The second not item is CTNF is not very restrictive, other than the rubrics on canopy protection and avoiding chemicals. But even these two items allow some limited exceptions. Beyond canopy protection and avoidance of chemicals, all silvicultural methods that fit a given site are acceptable if they improve the ecosystem. And finally, CTNF is not a barrier to oak regeneration. The 1.3 acre allowable canopy gaps in CTNF are larger than minimum recommendations in both the US and European studies. But perhaps the most powerful regeneration evidence is in its actual use. Although Europe is known for extensive beech-dominant forests, which of course are shade tolerant, Central Europe alone has over 60 million acres of oak-dominated forests where CTNF has been used extensively for the last 5 decades. Some areas have used CTNF for well over a century. Unlike single tree selection, CTNF is more ecological and more economically competitive. And now I'll pass the mic to Dr. Corder for the main part of today's presentation, the discussion of our research findings.
Very good. Thanks, Jim. The backdrop to our work is a landmark study in 2019 by the Cornell Lab of Ornithology that sought to estimate North American avian population trends over the past 5 decades, as well as some other studies that have attempted to assess how forest habitats influence avian population trends. Well, the Cornell study, led by Dr. Rosenberg, reported a staggering net population loss of approximately 3 billion birds in the United States since 1970, with the largest magnitude of losses being from forest birds. They refer to their findings in this landmark paper as a biodiversity crisis. This graphic from their paper shows avian families that suffered losses, as well as those who have become success stories for North America. Of the losses, many of the groups are predominantly or significantly represented by forest species. Of the few success stories, raptors have recovered from changes in agricultural chemical use Well, game birds like turkeys, grouse, or ducks have benefited from the extensive work by societies focused on helping these game birds. Meanwhile, many studies over the last few decades have been pointing to forest habitat fragmentation as the primary driver of avian population losses. The increasing forest fragmentation has been driven by land use change from regional population growth, urban and infrastructure expansion, and the growing wildland-urban interface. In Europe, avian trends have largely followed a similar path as those in the US, but unlike the US, European forestry trends have been moving broadly towards low severity management systems like CTNF. Interestingly, a collective effort by European ornithologists in 2022 that was recently published by Eurostat identified a landscape scale trend for forest birds that was positive over the last 2 decades, as shown in this graphic from their article. Although most bird population assessments in Europe are still rather bleak, this finding, albeit over a limited time period, supports a glimmer of optimism. Meanwhile, over the last 4 decades, CTNF application in European forests is extensive and is achieving landscape scale impact, as Jim described. Studies now suggest that CTNF management is being applied in 1/4 to 1/3 of all European forests. This implies CTNF use in as much as 170 million acres of European forests. And where CTNF has been most extensively implemented over space and time, like in Central Europe, recent studies suggest that the permanent canopy cover may improve, that's associated with CTNF, may improve forest bird populations and biodiversity. So thus our study tried to wrestle with the question of how timber harvest may affect avian habitats. The question is obviously complex because higher severity timber practices, which would be contrary to CTNF methods, are already designed from and supported and historically connected with ecological studies which seem to increase avian and general biodiversity in forests. Let me explain. So overwhelming historical evidence suggests that edge or early successional habitats improve biodiversity for birds, as well as a variety of other animals. Furthermore, removing forest canopies, which create early successional habitats, also supports forestry objectives to increase the regeneration of valuable species, such as shade-intolerant oak species, particularly white oaks. Thus, canopy removing silvicultural systems such as shelterwoods, seed tree systems, group selection cuts, and clear cuts support both ecological and silvicultural objectives, producing more biodiversity and more oak tree regeneration. Since US forests are increasing in their maturity, shifting the balance toward young forests helps both ecologists and foresters. Based on this alignment, one would assume that CTNF methods may have little value for US ecosystems, but finding studies of low severity timber harvest methods to compare with the status quo is very challenging. Our research suggests that evidence for or against CTNF in the US is largely non-existent. Examining peer review studies of alternative harvest methods and their impacts on avian habitats, one particular study, Salabanks and Arnett in 2005, reviewed 116 studies, but most, 54%, only assessed clear cutting. Only 11% assessed lower severity single tree methods, which would be the most similar to CTNF. And furthermore, 92% of those studies were at small local scales, and most had no statistical inferences or replicates. Given the oak-based preference for canopy removal and the limited application of single tree selection in the United States, landscape scale studies of low severity harvest methods are surprisingly rare. New studies, however, are assessing landscape scale biodiversity impact of high severity harvest techniques. They suggest that the temporary forest fragmentation from canopy removal can be bad for biodiversity. Two studies are noted here from New England and Canada, which suggest that even sustainable forest practices that temporarily removes canopies may slowly degrade habitats at landscape scales. Jim.
So as we reflected upon this new landscape information suggesting higher severity harvests actually degrade landscape scale habitats, we reviewed numerous forest management guidelines for improving avian habitats. In all, we reviewed 17 guidelines shown here from some of the top ornithological and conservation organizations in America, including the American Bird Conservancy, Audubon, Partners in Flight, the Nature Conservancy, several universities, and governmental wildlife departments. Without exception, each guideline suggested a balanced approach to habitat management. In other words, some forest birds prefer early successional habitats, some prefer mature forest habitats, some are generalists. Therefore, unless you're planning a large habitat area for a specific species, all manuals effectively recommend to manage the forest with a mixture of habitats, some mature forest, some early successional. And although all had a generally balanced approach, some also promoted one extreme of the management spectrum with a bit more emphasis. For example, the Cornell Lab guideline for scarlet tanagers and forest interior birds had numerous pleas for protecting mature forests. They noted that higher severity timber harvests will temporarily fragment a forest. They cautioned that interventions which increase local scale diversity can potentially cause declines in landscape scale diversity. They emphasized that mature forests benefit a wide variety of forest bird species. And since early successional habitats can be created quickly, while mature forests require a very long time to develop, they suggested that conservation strategies should focus on maintaining mature forests. Other guidelines, still supporting a balanced mix of habitats, emphasize the ecological value of early successional habitats. For example, the New England Forestry Foundation has developed an aspirational forestry approach for improved biodiversity and specifically for the benefit of birds. This guideline is outstanding in its ecological content. However, it prominently displays the following graph. As a support for their recommendation that 27% of Acadian forest area should be managed by even-aged blocks greater than 15 acres in size. The graph has a number of footnoted caveats, but the relationship of increasing avian richness with increasing clear-cut acres obviously emphasizes the value of early successional habitat formation. Another example is the guideline for forest birds in southeastern Ohio, developed by the Ohio State University and the Nature Conservancy of Ohio. This guideline was developed through extensive field studies in the same ecoregion where our research forest is located. Filled with graphs and data, this manual provides specific forest management recommendations for each bird species that was studied. From their field analysis, 51 forest bird species in this region were given forestry practice recommendations for the best habitat management. Of the 51 forest bird species, 25 species were given the preferred recommendation of clear cuts or canopy removal. Only one forest bird species was given a clearly preferred recommendation of single tree or fine scale group selection, and the remaining 25 species didn't have a preferred management practice. Acceptable options covered all degrees of severity from clear cutting to single tree selection.
Okay, so let's now take a look at our field results. First, at the local scale. These photos are from our study forest. The upper right-hand photo shows an example of our typical canopy gap created by a single harvested tree. CTNF gaps in this young forest are quite small. The photo on the bottom right shows an area classified in our study as an open canopy. This canopy gap is less than 1.3 acres, but still provides lots of sunlight on the forest floor, even though this is considered an interior forest gap. This large gap has promoted ground vegetation growth and expansion of an intermediate canopy. The photo on the bottom left shows the typical closed canopy structure of this forest with an absence of ground vegetation. Our local scale conclusion was that CTNF habitats attract both early successional and mature forest bird groups. In support of this conclusion, we wanted to highlight three particular observations from the data. First, you'll notice species mix. The question there was, did the CTNF habitat in total attract more interior forest birds or early successional species? The next heading is species richness, the different CTNF habitat structures, those being edge versus interior, and by different degrees of canopy cover. Did they present different levels of species richness? And finally, we looked at the sightings of individuals. We categorized species into two groups, mature forests and early successional species. And we examined each of these two groups by asking the question, did the individual sightings or abundance of these groups align with their normal habitat preferences? So in total, we observed 47 different species. Of those, 53% were early successional and 47% were mature forest birds. This CTNF habitat seemed to be attracting both mature forest birds and early successional species equally in this setting. Comparing the species richness observations in the different niche habitats, those being edge versus interior and by different degrees of canopy cover, we could not find any statistical differences. Again, the CTNF habitat and its structural niches appear to be attracting a similar richness of species. And finally, we compared the two groups as categorized by the Ohio specific guidelines, and the total number of individuals from each group who were observed in edge habitats were equal. Thus, we concluded that the CTNF-managed habitat attracted both early successional and mature forest birds, or in other words, you may not need a clear cut or canopy removal to support birds that prefer early successional habitats. All right, so many of you are probably familiar with eBird. Another kind of a piece to our analysis. eBird is an initiative sponsored by the Cornell Lab of Ornithology that invites citizen science observers to submit checklists of birds that they've encountered by time and location. Since its inception in 2002, they just had a 20-year report released. eBird observers have reported more than 1.4 billion bird sightings around the globe. And in many ways, eBird has revolutionized the way that ornithologists understand avian diversity, abundance, and range shifts. At a landscape scale, we utilized eBird observation data as reported for the county where our research forest was located. The map shown here outlines Tuscarawas County, which is 571 square miles in area. We chose to compare breeding season data between our CTNF forest and the surrounding county, grouping the bird species by conservation concern ratings as defined by the North American Bird Conservation Initiative. And the abbreviation is NABCI, North American Bird Conservation Initiative. Since eBird data protocols had some differences to ours, we defined a metric, established a metric to attempt to normalize the data sets. For example, our CTNF observations were based on stationary test point locations with fixed observation time duration. Likewise, eBird also has stationary observation protocols, but in some cases, there's traveling observations of varying durations determined by each observer's outing. Thus, for each observation event, we had to standardize this by calculating a percent of total species observed within 3 different conservation categories. So like standardizing it by a percentage. And the conservation categories we identified were high conservation interest, medium conservation interest, and low conservation interest. Our conclusion from this analysis was that the CTNF forest had double the proportion of high conservation concern species than seen in the surrounding county. For our analysis, we define high conservation concern as an NABCI, maximum combined conservation score, of 12 or higher. And we use chi-square tests as to statistically assess on these differences. While we feel our approach was justifiable and repeatable, we acknowledge that using eBird data to approximate landscape scale information about birds, as opposed to assessing populations at specific locations, is still a bit of a newer concept. We also acknowledge some practical limitations with regard to consistency in observer effort. For example, eBird reports are sometimes submitted in a disproportionately high fashion at popular eBird hotspots or in places that may be more convenient for citizen scientists to visit. To address some of these weaknesses, we recommend attempting to identify specific locations where individual birds are observed, not just the location where the overall checklist is submitted. And then if you could link the geocoded locations to specific land cover classes, this could ensure a more apples to apples forestry-based comparison between birds in similar habitats. The final conclusion for our CTNF study area is that this habitat appears to function as a complex forest system, providing both early successional and mature forest avian benefits. In this map, we show the research forest boundary containing white stars for our test points. You can see here. You'll notice some meadows are present, thus providing some open habitat in the middle of our CTNF forest. These meadows show up as the light gray areas near the center of the test forest map. When we measured these meadows with GIS mapping tools, however, we were surprised at how small they actually were in area. Their length makes them look large, but their narrow width really makes the overall area quite small. The largest is 1.2 acres, and an adjacent one is 1 acre. Another nearby one is 0.7 acres, and 2 others are less than a half acre. Interestingly, our meadows are smaller than the maximum allowable gap size in CTNF canopy protocol. So while our research forests may have benefited early successional species due to the presence of meadows, even these meadows are clearly within the protocols of the CTNF management system.
For our final slide, we wanted to raise the CTNF management option to a higher level question of forest biodiversity management. We'll do this with a graph from the Ministry of Forest Research in British Columbia that was also based on US research in the Pacific Northwest. Their graph shows biodiversity of a forest as it progresses through its several phases from extreme disturbance through ancient old growth. Perhaps not surprisingly, the highest biodiversity is achieved in the youngest stage of forest renewal. Young forests are extremely complex and full of diverse microhabitat niches. However, by the time the forest age hits a range roughly between 40 through about 150 years old, its biodiversity is in a very low trough. The closed canopy has slowly extinguished the microhabitats in the intermediate canopy and ground vegetation. Then, as the forest ages past 150 years, large dominant trees slowly senesce and fall to open the canopy with gaps that allow structural complexity and increased biodiversity. This graph suggests that old growth forests never achieve the biodiversity of an early successional forest. With respect to avian habitat management, we see extensive evidence and recommendations that to create more early successional habitats as forests in the US mature. With a growing proportion of mature forests sitting in what I would call the biodiversity trough, forest management strategies want to move our forests to the left on this graph. This move to the left strategy supports both ecologists and foresters. Ecologists with improved biodiversity and foresters with canopy removal for improved oak regeneration. Thus, with a balanced habitat management guidance, historical practices promoting canopy removal are likely to continue. Now, one ecological downside of the move left strategy, however, is that the high biodiversity of a young forest is very short-lived. In fact, the x-axis on this graph changes after 100 years. And so it exaggerates the duration of the early years as biodiversity degrades very rapidly. Thus, as you pursue a strategy to shift forests to the left, the high biodiversity drops quickly as the forest heads for a very long wait in a 100-year-long biodiversity trough. As an alternative strategy, CTNF shifts the forest to the right. It maintains mature forest structure while promoting canopy complexity and habitats that attract early successional species. With the 9 harvests that we've completed in the last 7 years, the economics of CTNF have been attractive. And given the long-term oak regeneration success in the oak-dominated forests of Central Europe, there is reason to hypothesize the same could be possible here. Of course, disturbance-based, uneven-aged forestry systems in the US have similarities to CTNF, but their use here is still modest. Europe, by contrast, has placed a very big bet on CTNF, with estimates of its use now approaching 170 million acres of European forests. Even their forest equipment industry has responded in recent decades with nimble harvesting equipment designs that reduce costs without damaging forests. Our study may be too small for any revolutionary conclusions, but our Ohio results and Europe's extensive use raise a question for us. Should the US pursue more move to the right forestry systems like CTNF on a much larger scale to the benefit of birds and general biodiversity? Our hypothesis is that a much larger portion of US forests need management strategy that move them to the right, toward old growth. We hope our work raises questions in your minds and prompts further study and actions. Thank you. And by the way, I think we're going to have copies of this available, and we have 4 more pages of all the citations just for your benefit.
Yeah, thank you. That's a great addition, and we'll send out the citations when we send out a link to the recording. Well, thank you both for a great presentation. Really interesting to see both the specific results, and I enjoyed having it placed in that context. So one question has come into the chat, well, sort of 2 questions have already come into the chat window. I encourage other folks to add questions. But Sally asked, first of all, in the specific study, how much of the surrounding landscape is forested versus other habitat? And if you could speak a little bit to, I think you touched on this a little bit with some of the eBird data, but it feels like that's a key element.
Yeah, that's a great question. So again, on 122 acres, it's within the 273 acre mature forest. So Tuscarawas County, so the county where this is located, and frankly, even some of the surrounding counties within Ohio, I would call them. There's one county that has a higher categorization by the U.S. Forestry Service in terms of forestry cover, but I would say this is in sort of they put it in the ranging from 50 to 70%, 75% forest cover. So it's. Ohio landscape is highly fragmented. We've got farms all over the place, we got roads all over the place, lakes, etc. So it is highly fragmented, but it's in their upper tier in terms of forest cover as a county.
Great. Then another question that came in was about close-to-nature forestry being used successfully in other forest types, such as spruce fir, as opposed to the oak, hickory, or northern hardwoods that you're looking at here.
Yeah, that's a great question. And I think when you look at use of CTNF within Europe, there are certain regions like the Scandinavian regions where they have been, I'll say, almost pushing against it for a lot of years. They're starting to use it, but I think estimates are maybe 3% of their forests or even less are using CTNF. But I definitely see areas where they're using, in conifer forest. That's not my area of expertise, but whether it's up in Scotland, Ireland, and in other regions, I see a lot of material on conifer forest. That's not my sweet spot, if you will. But it appears to be used in some cases.
Yeah, and I mean, I think sitting out here in New Mexico, it's always important to recognize, right? We're working with different disturbance regimes, and up in Colorado, lodgepole pine, right? This is not an appropriate forest system for lodgepole pine. It just doesn't match the ecology. But I think it does connect in with guild efforts to understand, like, okay, how the overall paradigm of being close to nature matches the guild's idea of using nature as a model, and it also requires a deep understanding of what the natural patterns are. But I should turn out to other folks' questions here. Let's see, Tyler asked whether there was site replication beyond in the Ohio study.
Well, okay, so we had the 12 different test points. So that at one level that had a degree of a replication, but at a broader forest, we have not been able to do that yet, and that's sort of future on the list.
Yeah, the test spots were over 100 meters apart on average, so there was pretty confident that most of the time the birds were separate birds we were observing.
Good point.
Good. Okay, that's an important detail. Let's see, I'm going to jump to a question about invasives. Did you see a lot of invasive plants colonizing in the canopy gaps?
You certainly do see more popping up in the canopy anytime you have edge effect, kind of the multiflora rows and these kind of, autumn olives, etc. So, yes, we saw some. We definitely are seeing some, and we're sort of debating on, what do we do with, how do we treat that in the future? We just let it progress. We've done some studies on things like ailanthus in this forest where we're using only mechanical and no chemical treatment on for the treatment of ailanthus as an invasive. But yeah, that's the more time goes on, the more we're going to see how big of a problem this is. At this point, nothing's panicking me or my foresters yet, but
Yeah,
I would also maybe make the comment that we also have an environmental engineering group team that I typically work with on these properties, and I'll ask them questions about invasives and different they're constantly assessing properties across the forests across Ohio, and there of course are lots and lots of invasives that when you're under the canopy, you just don't see them as much, and there is that the canopy in itself can at least help you control some of those invasives. It's not as favorable to them.
Yeah, no, definitely. Gil did some work in New Jersey, and if you ever want a view of what the sort of invasive apocalypse looks like, some of the New Jersey forests are really scary, because there's the prevalence of invasives, the deer browse, and the difficulty of managing, and I think that it challenges the Close-to-Nature Forestry prohibition against chemicals. And I think it's an interesting conversation, I think, within the Guild, within our profession, about where we draw some lines. Because there are times when I sort of feel like, you know what, this is what we need herbicides for, but not our debate today. So let's see. Gordon asked about, when considering biodiversity, do you include herbaceous and understory plants, or is your biodiversity exclusively focused on birds?
Well, ultimately, we would define it in the broadest sense. Birds are a good indicator because, you know, within the food chain, if you've got good coarse woody debris and insects and beetles and lots of other kind of within the food chain, it does help them. But we have not done any conceptually, and in terms of our efforts, we define biodiversity in the broadest way possible. But in terms of our actual studies and what we're measuring and recording, it's been sort of birds at this point, and more to come, and plants. Go ahead.
Yeah, I think that's a real challenge, you know, to like measure the ecosystem services, like what's the dependent variable as broadly as you can. I think the better. As Jim mentioned, your birds are a really good bioindicator, we think, for multiple reasons. But, you know, even thinking about like ecological benefits of carbon sequestration and, you know, healthy communities that are resistant or resilient, or, you know, that have variety. I mean, I think that's also a future area of research, because a lot of the papers we've read are really taxa specific. So we're at least kind of thinking, even though we're focusing, we are also taxa specific, but kind of thinking, trying to frame things more broadly in terms of the overall ecosystem benefit.
Yeah, great. So there's two questions I'll combine here on harvest practices. If you had any suggestions on European forestry removal machinery versus kind of standard use in Ohio, particularly around soil compaction and danger to trees. And I want to tie that into training techniques and equipment that might be sort of particularly common for continuous cover or close to nature forestry.
Yeah, these are great questions. And one of our biggest challenges has been developing logging partners and sawmill partners who have the capability to do this. And I've been even surprised within Ohio that we're a little bit, we're in southeastern Ohio, but we're a little bit more central, you know, a little further north. And there's a lot of Amish communities around here. When we take bids on these CTNF harvests, first thing we ask them is, okay, give us a list of the equipment you're using, and you know, if it's a narrow gauge dozer, we do not allow any hydraulic grapples. We want all cable skidding, and that's not a problem where in most of our forests, although some, as we get further southern Ohio along the Ohio River, there's a lot of really big sawmills down there, and sometimes it's tough finding loggers who even they just have big automated equipment, you know, the feller bunchers and those type of things that are, you know, they're safer for the operators. There's a lot of good advantage of them, but they just destroy the forest. And so, yeah, that's we've developed a partnership with about 5 or 6 logging companies right now, and who work with us. And we watch timing, you know, how much rain has there been when, you know, accessing the forest, how wet is it, some things like that. But we've had very low logging damage.
Great. Yeah, I think that's
yeah.
Oh, go ahead.
I'm sorry. One last thing too. I gotta put a little plug in here for Ed Romano, because in that first picture you saw of him, he was instructing the loggers. And when we mark every tree. Okay, these are the trees we want harvested. Ed typically will tie a ribbon around bumper trees. He'll walk the loggers in. This is how I want you to bring your equipment in. It's okay to bump against this tree. Here's a turn. I mean, he really, and he knows where there are problematic areas of the felling could get a little bit tricky because there's some really high value trees. We don't want damage to the resulting stand. So yeah, equipment's a massive thing. Although in our case, sometimes the oldest equipment is the best, the new stuff that they're putting in, they're buying, some of the loggers are buying big new equipment that does a lot more damage. But then the other side of it is you have people that have the skill in directional felling and cutting.
Yeah, great. Let's see. I want to point people to Sally's comment about the Forestry for Maine Birds program, and diving into some of the details there, where it promotes more structurally complex older forests. I also put earlier on in the chat window, and maybe I can repaste them, links to previous Guild webinars on management to promote old forest characteristics in different forest types across the country. So I think all these things are somewhat related. So Roger had a question, or a little bit more of a comment about the early successional habitat and edge habitat and sort of differences and similarities. And he points out that in Massachusetts, the guidance has been that the edge part of any size gap opening is the least valuable due to high predation for bird habitat. And then thus the recommendation for early cereal habitat openings be at least 5 acres in order to increase the non-edge component. So some of those trade-offs, and which may be driven partly by particular species.
Yeah, good input.
Yeah, I've seen that too. Some papers say like 50 meters or so but edges seem to be really attractive for birds, but some people have called them ecological traps. You attract them there, but then they face, as was mentioned, more predation, more competition, more brood parasites like cowbirds and things like that. So, and maybe even the birds show up there in migration, you count them, they look very healthy, but when you actually look at true nesting success or overall impacts, they might be a little bit rose-colored.
Yeah, it's a balance, I guess. Let's see. Ken asks when the bird surveys were done, and were these breeding bird surveys, presence, absence, and also maybe what you want to turn to first, given the last question, is are the edge species or edge habitat specialists equivalent of early successional bird species?
Yeah, in most cases, to answer the second question, yes. I mean, that's kind of how they were classified, but we were surprised that there was a good mix of early successional species, throughout our forest in both the interior spots and more edge spots. So the bird surveys, Jim, you can mention that, but they were done kind of from February to July yeah, with an emphasis on the migration season. So yes, the migration season also was included. I think that was, I'm just reading that in the chat.
Yeah. So at the local scale within our forest, we looked at through migration as well as breeding. But then when we did the eBird comparison, we did May through July, so it was a bit more of the breeding season.
Great. I think we'll let Sally have the last question, and she asks, can you expand on how frequent the harvesting is that you are recommending?
Yeah. So yeah, this can be a contentious point at times, and especially with our foresters we work with over here, and I think people get concerned about frequent access can have a degrading effect on a forest too. And so how you plan out skidding trails and access points and things like that can be quite important. The frequency is generally dictated by the growth rate of the trees, and so like in the in a lot of the European manuals, and I've been surprised at some of their growth rates as being typically growth rates. We're just measuring DBH growth as our indicator, but sometimes their growth rates seem to be a bit slower than we're seeing here in Ohio anyway. But their ranges for, let's say, they would call them fast growing species. So as an example, conifers, pines, those are very fast growing. They would, in some of the manuals I see, every 5 to 7 years going in for another harvest. Whereas over in Europe, their broadleaf recommendations are probably more like every 10 to 15 years. Now, based on our Ohio growth data, I would say we're probably, the current target we're running at is about 4 to 5 years, every 4 to 5 years. And you know, we're experimenting with this. The experimental forest that where we did the study, we've done well, I was about to say, well, we did 3 harvests in the last 7 years. We actually just marked up a new harvest and got it under contract. So they're going to be going in this summer on a 4th harvest in, let's say, you know, 9-year period, 8-9-year period. Now that and we're not; those are all overlapping harvests. So it's spatially. So it's not like we harvested the North 40 and you know, in year 1, and then the Southwest 40 in year 2 or whatever. All of these are overlapping, and partially because we're kind of experimenting as we go, and we're saying, okay, let's do a light cut. Can we get a sufficient cut to actually get it out to bid and you know, get competitive bids on it? Yes. You know, how complex is it? All those kind of questions. And then we'd observe the forest, and we're saying, I think we can go back in here again. You know, 1 or 2 years later, we're thinking, I think we can go back in here. We have some other areas we didn't touch yet. Let's you know, go back in. And these are overlapping a lot. That's not our general plan. That's our research forest. Our general plan is about every 5 years, let's say.
Great. Well, thank you both again for a great presentation, stimulating some great conversation. And yeah, I look forward to other opportunities, whether maybe we can get out of the field and talk about some of this stuff, or it is fun on these webinars to have folks from different regions connect. So I appreciate you getting us going here, and look forward to other connections. Thank you so much.
Very good. Thank you. Thanks, everybody.
Okay. Have a great day.